Hey, this is Mrs. Reichelt, and before we get started with our podcast, I'd like you to please pay attention to this table right here. Make sure before you start the notes that you actually have a copy of this. It would be easier if you had a copy that you can just write out. If you'd prefer, you can use the notes features on your iPad or whatever you have at home to copy down the notes as well. So basically, we already talked about tissues, but there are 4 major tissue types, and they are already located over here for you. So the tissue type, we have epithelium, muscle tissue, connective tissue, and way down at the bottom, nervous tissue. So you'll notice that in the next couple of podcasts, it'll take a couple of these for us to actually go through each tissue type, but you'll be filling out the location, the function, the characteristics, the classifications, and then you'll be writing a couple of little things about each of the examples. Okay, so this document should take you probably 3 or 4 podcasts to fill out the entire thing. You don't need to turn in this podcast or these notes. They're just for you. It's not an assignment, so it's not required. So let's go ahead and get started here. Okay, so again, the 4 tissue types that are already written there for you, so you don't need to copy those down again. You have epithelial tissue, connective tissue, muscle tissue, and nervous tissue. So we're in the very top in the epithelial tissue type. For the locations, I'd like you to write down body coverings, body linings, and glandular tissue. Then the next column over, under the functions section, you'll write protection, absorption, filtration, and secretion. Okay, so now we go ahead and move to the characteristics column. Hopefully this makes sense to you as you're filling these out. Cells fit closely together and often form sheets. So maybe to get this a little bit so you don't have to write quite as much, maybe write cells are close together forming sheets. So cells, they're close together, sheets. Okay, in addition, the apical surface is the free surface of tissue, and there's a diagram of that in the next slide, so I'm going to wait to define that until a little bit from now. So the apical surface is a free surface. The lower surface is the basement. So apical, free surface, lower surface is the basement. Epithelium is also avascular. That means that there is no blood supply. Remember, usually when there's an A before something, that means without. In addition, epithelium regenerates easily. When it talks about nourished, we're specifically talking about if there's oxygen. If it's oxygenated, then it'll regenerate very easily. Okay, so here's the difference between apical and the basal surface, or I guess last slide it was the basement surface. Apical just means that it's towards the outer part of the body. Basal, or the basement, means it's below. Okay, so the inner would be here, outer would be here. Okay, so the classification of epithelia. So now you're in the next classification column. So there are 2 ways that epithelial tissue can be classified. The first is by the number of cells. So an example, if there's simple in the word, then it means there's 1 layer. So simple is going to mean 1 layer. Stratified means there's more than 1 layer. So if you look at this picture, there's 1 layer, so it's simple. There's more than 1 layer here, so it's stratified. So the number of cells, or at least the number of cell layers, is the first way that epithelial tissue is classified. The second classification is by the shape of the cell. So this is the second way. Squamous refers to flattened cells. So if a cell is flattened in appearance, then it's squamous. Cuboidal means cube-shaped. So if it has a cube kind of shape to it, looks like maybe a square. And then columnar is when it looks column-like. These classifications are really helpful when you're actually going through and giving out examples of epithelial tissue, because it's really easy to think about what the tissue actually looks like. Okay, so simple squamous. Hopefully this makes sense. Okay, by the way, we're in the examples now, so go over to the examples. You'll see that there is simple squamous is already written out for you. So all you have to write, and if you don't need to write this, that's fine. Simple means single. Squamous means flat. So it's a single layer of flat cells. This usually forms membranes. What I would write is lines body cavities and lines the lungs and capillaries. So here's a picture of simple squamous epithelium. Okay, so this right here, we have the basement membrane down below. We have the apical surface up above. So an example would be the air sacs of the lungs have simple squamous epithelia. Next up, simple cuboidal. Simple meaning what? Single layer. Cuboidal meaning cube-like. So do you see how, as long as you know what these words mean, you can really figure out what it will look like. What I'd write down here is they're common in glands and ducts, and they form the walls of the kidney tubules, and they also are going to cover ovaries. So here is a picture of what this is going to look like. So this is a diagram of the kidney tubules, and you'll have a couple of labs where you'll get diagrams like this, and you'll have to determine what type of cells you're looking at, what type of tissue it is, and that sort of thing. And once we go through all of these, I think that it'll kind of make sense to you. So here we have the basement membrane. You see how these are more cube shaped, but there's just one layer of them. That's where we get simple cuboidal. Next up, we have simple columnar. Simple meaning single layer. Columnar means it's going to be those tall column-like cells. Simple columnar often includes mucus-producing goblet cells, and they're also going to line the digestive tract. So some pictures, you see there's one layer and they're in tall columns. Okay, these ones I think are pretty easy to identify because they're tall columns of one layer. So that'll be the simple columnar. Next up, we have our pseudo stratified columnar. Pseudo means false. Stratified means what? So stratified means more than one layer, but if it's false stratified, then we're still a single layer. Columnar means that they're going to be in columns. So this one's a little bit different. You have a single layer, but some cells are shorter than the others. Most of the time, this looks like a double layer of cells. So when you're looking through the microscope and when you're trying to identify tissue layers or tissue types or cell types, make sure you really are paying attention to whether it's one layer or two layers, or if it looks like two but it's really one, those kinds of things. They can be a little bit tricky. Sometimes pseudostratified columnar is ciliated, such as when it appears in the respiratory tract, and this may function as absorption or secretion. So here are some pictures, and here's why these can be a little bit tricky. when you look at this diagram, see how they're all different shaped? They kind of had an odd sort of shape. These ones look like there are two of them, but this one goes all the way down. That's why they look a pseudo stratified epithelial layer. So it's all one layer, but they just look a little bit different. Okay? Okay, so next up, we are in our stratified squamous. Stratified meaning what? More than one layer. Hopefully you got that. Squamous meaning flat. Cells at the apical surface are flattened, and they're found as a protective covering where friction is common. So good examples of this is skin, mouth, and esophagus. Okay, so here is some pictures or some diagrams of, let's see, I think that I did something. Okay, here we are. Okay, so our stratified squamous is going to look like many layers. So you have many layers here, but they're all going to be flattened. Okay? Okay, so really quick here, stratified cuboidal, you'll notice, is not even a section in here. So, I meant to leave this out, but what I'd like you to know about these, and you can put this in the top part of your notes if you want, basically stratified cuboidal, there are two layers, which means stratified, cuboidal, they're cubed shape, okay? Really, the reason we didn't put these in is they're rare in the human body. They're found in ducts of large glands. So you're not actually going to have to identify any of the stratified cuboidal because they're very rare in the human body. That's just kind of a fun fact for you. Don't worry about that it's not in your example section. You won't have to identify those, but just be aware that there is a layer. I wasn't just skipping one, but it's very rare. Okay, so moving on to transitional epithelium. The shape of the transitional epithelium depends upon the amount of stretching. So here's where you have to think of all the types of organs that are going to stretch out. So these are going to line the organs of the urinary system. So your bladder is going to stretch out with the presence of urine. Okay, and then it'll shrink back up after you urinate. Okay, so here are some pictures. So transitional epithelium, when you identify these, you'll see that some of them are pretty small and then some of them get wider. So basically, as fluid enters, they're going to change shape around the material. So transitional epithelium is going to depend upon the shape of the stretching. So the stretching is going to determine its shape. And then the last one, we have glandular epithelium. So first of all, you may want to put that glandular means that it's going to be secreting something. So gland, secreting. That's really all you have to put under the glandular. And then there are two types. We have the endocrine gland, which if we want to be pretty short here, endocrine is going to diffuse into blood vessels. That's all you really need to write. You don't worry about anything else. Endocrine gland, we're diffusing into blood vessels. Exocrine gland, we're emptying through ducts to the epithelial surface. So we're emptying via duct pathways, and sweat and oil are examples of those.